Hi, my name is George Hemingway. I am the Innovation Practice Leader for Virtual Consulting International. I'm out of our New York office.
And I'm Jeff Lair, Managing Director of Virtual Consulting International's New York office.
We're going to take you on a journey today through our presentation on strategic futurecasting, asking what can scenarios of the future teach us today? You know, they say to predict the future is a fool's errand, and some might accuse us of doing exactly that. Hopefully, we'll have a little bit of fun at their expense. Nonetheless, we have good company. Over the years, the results of people trying to predict the future have been more wrong than right, and the prophets of the past have failed to foretell the future any better than dumb luck could.
Now today we're not trying to predict the future. We can't as much as we might wish to. What we can do, and what has been done with success, and what we will try to do today, is to paint a portrait of possibilities, a collage of imagination, and to see through this quilt of space, time, and technology and trends what shared principles exist and what we from them may learn. By way of introduction, VCI is a global strategy and innovation consultancy focused on helping the resources sector to grow, innovate, and transform for today and tomorrow. We spend a lot of our time helping CEOs and innovation leaders to think through where the world and mining industries are headed and how companies, capabilities, and industries can transform to lead, capture, and sustain advantage and value.
Now, as part of that, we frame up and execute Mine of the Future programs, and today we'll be taking visions of the future from our clients, and that we've also gathered in R&D pipelines from our suppliers, and blending them with broader technological, societal, and macroeconomic trends to paint multiple portraits of possibilities. And what we're going to do is look for shared principles within those scenarios of the future and seek out lessons for today. And as we travel through the future, we're going to explore 4 different visions. 2 focused on operating models, 1 focused on an organizational, and 1 focused on the business model.
But before we can begin, we are going to frame up the borders of our worlds and ground ourselves in reality through an exploration of macroeconomic and mining trends, and then we'll build within those borders. So let's begin. We have identified a number of trends affecting the mining industry and impacting how it will develop over the next 20 years. In a very real sense, we have moved from a sated market of 700 million to an underserved market of over 3 billion people, and this is a great opportunity for mining. Global interdependence will increase and commodity demand will continue to grow despite potential short-term pressures and cyclicality.
Now, looking at the resources to meet this demand, much of the easy resource is gone. So meeting it is going to require mining either more difficult ore bodies in more challenging locations or even more extremely remote and low-grade and complex ore bodies.
We see more pressure from sovereign influence for safe, low-impact operations that give more back to communities in which they operate. If this is not addressed, then the trend of sovereign nations stopping or delaying projects and demanding larger pieces of the economic pie is sure to continue.
Now, we've seen increases in extreme weather events and even more dramatic increase in the perception of extreme weather. And this is driving major shifts in public policy. We believe will continue to do so. So a greater environmental sensitivity is likely to impact all businesses as a result of climate change or demand for scarce air and water.
A clean, cheap energy source could lead to new solutions, while limited energy will drive conflicts. Energy uncertainty is huge, since most of the problems that we face can be relatively easily solved or even exacerbated with energy-intensive solutions.
Fortunately, technology is developing at faster rates to meet the challenges, and as the improvements build on the improvements, the exponential results will change the way we work, operate, and even think. So, what do these trends tell us about where mining companies will need to innovate?
First, we know that we'll need to create scalable operations in order to take advantage of market shifts and profit from cyclicality.
For example, looking at the shift right now, reducing cost structure is incredibly important and will continue to be so to survive downturns and maximize returns.
This also means that we'll need to develop flexible platforms to work in challenging, diverse, and remote environments.
And we're going to continue to have to focus on eliminating all human hazard, eliminating all harm regardless of the geological complexity to satisfy those localities and to eliminate safety-related stoppages.
We'll need to reduce variability and mitigate risk in order to ensure consistent operations and production, making mining more like a factory.
Exactly. And we'll have to address environmental issues to reduce the impact upfront within the operations design. You know, Churchill said, "The empires of the future are the empires of the mind." We've framed up our worlds and their borders. It's time to do some empire building. Let's begin. The year is 2033. The place is Montreal, Canada. And we're beginning our journey at the headquarters of one of the world's largest diversified mining companies. As we enter the remote operating center, we see a diverse group of planners and engineers and operators standing around a hologram of an open pit mining operation. Within an isolated terrain exists an autonomous and robotic mine. We call this the rock factory. In this scenario, we still break rock, we still explore for ore bodies, and we still do it with relatively large mining machines. And from that perspective, it's not so different from the world of mining today, but what makes it different and more like a factory is that everything is optimized to be predictable, stable, and transparent, with variability in inputs and outputs and throughputs kept to a minimum. A vast amount of data is collected, and really everything that can have a sensor on it does.
Exploration begins with a series of robotic drones, flying autonomously across the sky, blending a combination of above-ground and below-ground sensors and advanced predictive analytics. These birds provide the control center with near-perfect visualized ore body knowledge as well as detailed information on fleet location and other above-ground inputs. This perfect real-time ore body characterization and fleet data play into planning and operations in real time.
Now, the rock factory is mostly run by autonomous machines and robots. These robots, they work the mine from exploration all the way to processing and are connected in real time to each other and to the main operating center. Mechanical rock breakage machines and blasting mixed with bulk lasers and remotely operated drills combined with robots and electric-powered trains. But what's really important is that the rock is flowing inside and outside the mine continuously. Now, as above and below ground physical human-machine interaction becomes less frequent, what happens is that humans work more with an exception-based type of management style. It's only when something goes wrong that humans interact and the machines communicate with the outside world. If you're looking at this situation, a human in a mine would be in a robotic exoskeleton to protect him from the environment. And when they get there, they would already know what was wrong with the machine to do the maintenance. They would go ahead and instead of waiting for the part to come, they would literally underground print it right there with an underground 3D printer and replace it. And what we're looking at here isn't just the future of supply parts and components, but also perhaps the future of all mining supply, where suppliers present you with IP and the mining companies print the machines themselves.
So what are we seeing here? There's a clear cluster of technology working together to create a step change, a systemic benefit that no one technology alone can make happen. We see this with our clients all the time. It's working together where the real synergies occur. What is the systemic cluster we are seeing here? It is automation, full mechanization, new breakage technologies, continuous miners, advanced robotics, sensory awareness, biomechanical symbiosis, and 3D printing. None of this is new. All of this is, in one form or another, happening today. Full mechanization and automation have existed in civil industries and some mining applications for years. And even some VCI-led technologies are finding their way into mining today, such as articulated tunnel borers and tunnel borers with laser preconditioning. These cement and rebar eating machines could someday find their way into mining as well.
As for advanced robotics with sensory awareness, one need not only look any farther than the U.S. Defense Department and the projects like Atlas Robotics, showing that uneven and dynamic terrain is really no obstacle to change.
Now, it's no secret that drones are second nature in military and law enforcement, but getting them to work autonomously and in complex environments has been infeasible until now. Here's an example of a U.S. Navy drone auto-landing on an aircraft carrier at sea.
And while we're on the subject of planes, what we're looking at is a 3D printed rocket part that NASA has put through the paces and that has passed.
Now, just to make a point, what you are looking at here is the realization of Winston Churchill's dream. And when he predicted that we would no longer need to make an entire chicken just to eat the wings and breast. This is a biologically printed hamburger.
And just in case you're wondering, everyone agreed it really needed ketchup. Now, burger-eating humans and their hearts need to keep safe underground, and on the rare occasions when they enter, here's how they might do it. Within exoskeletons, like this one that the Army has built to super strengthen soldiers and help the paralyzed to walk. I think you get the idea. So let's move on to our next world. Way on the other side of the world, deep underneath Johannesburg, a mine is alive, literally and figuratively. Not that you could tell from looking at the surface. This is the living mine, a true symbiosis between nature, man, and machine. The mine enables us to work in a more precise way, a sustainable balance, a new form of mining. What we're seeing here isn't bigger mines with more expansive machines and operations, but a blend of nano and micro technology enabled by advanced materials and underground biological processing to leach and refine and bring the materials to the surface, processed and ready to use. What makes it alive? 4 things. The nanobots within this mine move with a swarm consciousness enabled by a form of adaptive swarm logic and artificial intelligence. The processing and leaching solution here is literally alive, enabled by bacteria that can literally eat and transform minerals. They reach down to the smallest ore and they bring back the goodness. Now, like a natural organism, it creates a technological ecosystem with impact on the surface kept to a minimum, and a true closed loop exists. Everything from the manufacture of the bots to water, energy, bioleaching is done underground. And finally, when man and machine interact, because you can't actually go down there, they do so through taking control of a nanobot, and people literally doing it through virtually enabled avatars. So apart from the obvious, what makes it remarkable and different from the rock factory?
First of all, you can't actually see in real time what is going on underground. And variability is not the enemy here, as intensity and opportunity can change on a day-to-day basis. Instead, you're relying on the adaptability of aware machines and intelligent interconnected machines to adapt quickly and dynamically to the changing environment.
Also, everything is processed underground, and biological solutions extract remaining or hard-to-reach materials regardless of the condition. And to that end, unlike the perfect ore body knowledge in the rock factory, here exploration is kind of directionally accurate, and the nanobots give you more precise information as they mine.
There's much more reliance on a broad pre-designed approach rather than day-to-day monitoring of every action, and exceptions are expected, accepted, and designed around.
So in the end, previously unminable resources become mineable, and you've got an in situ, lower cost, lower impact approach. But you know, the thing that is like the rock factory is that you do get a consistent stream of refined product.
So what is the systemic technology cluster we are seeing here? A lot of what we've seen in the rock factory applies here, but there's a distinct cluster as well. Nanotechnology, advanced materials, artificial intelligence, biomining and genomics, leaching, a fully closed loop for energy, water, machines, and more. Much of this is cutting edge and a little further out than the rock factory, but all of this is in one form or another being demonstrated today. Some examples. Billions of microscopic devices working in tandem is not science fiction. GE, Hewlett-Packard, Northrop Grumman, and others are at work on nanotechnology and robotics. Nano cars have been built that drive, and within medicine, nanotechnology is being used to deliver targeted chemotherapy directly to the cellular level.
You know, even more interesting than the nanobots themselves is the intelligence they possess to learn and work in tandem. And this swarm logic is kind of connecting them and getting them to adapt. And what you're seeing here is you're seeing this swarm logic is work to overcome an obstacle.
All of this suggests a type of artificial adaptive intelligence and awareness which mining machines in the future may have.
What you have here is a hexapod that lost its leg and couldn't ambulate. It went through a number of different permutations until it found one that worked, and then it moved forward.
And this isn't just for small machines either, but for machines that could be used in mining today. This has been developed for the US military. It's called Big Dog. Essentially, it's a haulage robot, and look how it adapts to changing environment. It's so organic that it's actually a little bit creepy.
Now, another cluster of technology is advanced genomics to enable biological mining. And what you're seeing here is bacteria giving off an electric charge, attracting and concentrating metals. And it's going through the brine and producing calcium, magnesium, and potassium straight from the brine over a period of 1 hour.
Now, when we talk genomics and nanotechnology, we also need to recognize that these things enable a host of other benefits, such as these self-powered, self-contained sensor stickers that can go in any mine. Other advanced materials as well, such as lubricants and coatings, can minimize downtime, create stronger and lighter parts, and extend the life of machines. This type of technology will fundamentally change a mine's energy profile. Exploring the operations and the technology that implies is a lot of fun, and that takes a lot of our time. But we also think a lot of the magic is going to come from the organizations and how the organizations are actually designed to deliver on this technological promise.
We think in the future humans will be doing one of three types of tasks: prediction and planning, monitoring and maintenance, or focusing on demand and delivery.
Now, prediction and planning can be thought of as the management of the future. When we have all of the data available and all of the information available about what's going on in the mines, we'll no longer need to think about all of the day-to-day operations, but can rather be thinking about different scenarios of the future and what's coming, and then program those into our future operations and our mine plans that are going to be coming up. And we can do that within our remote operating centers. Now, everybody has an idea of what a remote operating center is, but we see remote operating centers expanding and changing, both geographically as well as functionally. On the geographic front, we'll be operating more mines from farther distances, and people will be able to dial in and come into remote operating centers from afar without having to come into one building. And in terms of increasing the functionality of the remote operating centers, as we move into the monitoring and maintenance, it's going to be people being involved with the mines on an exception basis when something goes wrong. And we see the functionality of being able to do this coming into the remote operating center. Here we have an individual going into a virtual reality room, and he's going to actually go and control the machinery underwater to fix some equipment that he's working with here in this virtual reality room. Now, we can also imagine a situation in which instead of just being in a virtual reality room, he may actually be connected to the machine itself, where it's an avatar, and he actually sees and smells and feels exactly what the robot sees and smells and feels as if he were there, allowing him to do much more tactile work and much more humanistic work rather than just remote control type of operations.
So kind of like the Matrix for mining.
Kind of like the Matrix for mining.
All right, so really, what does that mean that humans are doing in the future? Humans are managing by exception. As Jeff said, they're only getting involved when something goes wrong. Instead of mining, they're designing, programming, and maintaining. They're not looking at today, but looking forward and evaluating scenarios. They're managing human factors in demand, and most importantly, they're being collaborative. And I see this all as very good news, because it means that our robot overlords have not yet taken over. We still have some sort of purpose in the future. So, as we look at the technology clusters here, what are we seeing? We're seeing big data. It's got to happen. In order to collect all that big data, you need to have sensor ubiquity. You've got predictive analytics so that you can take that data and somehow look forward instead of trying to shuffle through a myriad of data. Visual modeling, because humans need some way to compute what's in front of them. And, of course, exception-based management. We're looking at virtual reality and remote operations. The last world we're going to touch on is that of the business model. What do all these technological advancements and these operating models and these organizational opportunities mean for the mining company of the future? Well, we think they mean a number of things, starting with mining companies in the future are going to be future-focused and oriented towards what is coming, with less of an operational focus. I think this is a point we've touched on in many different aspects.
We think they're going to be resource-driven, so using perfect information to value, buy, sell, and trade resources. And we may see mining companies becoming more like oil companies in that respect.
In that respect as well, they're going to be more market-creating, concerned about the direction of market demand and driving the market direction itself.
They're likely to become more customer intimate and able to consider customizations or new types of products for their customers.
And continuing with a look on the outside world, they're going to be more supplier collaborative as a strategic lever around R&D, technology, and CapEx. And if you look at that from a visualization point of view, really what you're looking at is that mining companies are going to be more collaborative suppliers around technology, more focused on creating a pull and customer demand and creating some ability to customize. They're going to possibly outsource their operations and focus on their assets, and they're going to really make sure that there is transparency and collaboration with stakeholders. And that's kind of what the mining company of the future could look like.
I think one of the key ideas here is that it's a more porous company where people will be collaborating from the outside with people from the inside, and also more market orientated rather than focused just on the mining activities of yesterday.
So let's look at those main principles. What are the shared principles of the four worlds we've seen? One, mining companies are going to become much more future focused.
Data-driven decisions will be the central organizing principle of the organization.
And instead of technology, how you break rock, it's really that the organizational and technological infrastructure could be more important than the actual bits of technology itself.
And the role of people is going to shift from production delivery to more high-level analysis, things that only people can do well.
And the mine itself is going to work more as a system. When you have a continuous factory type of operation, everything needs to flow together. And when something goes wrong in the beginning, it affects everything going through the system.
Now, people will definitely be separated from the mine, and interaction will be machine integrated, and this is going to help keep people away from harm and ensure a safe mine.
Unlike today, where companies focus on where the people are, or the machines are, or the ore are, the future is going to be less about crowd control and more about strategic management.
And finally, the lines between miners, suppliers, and stakeholders will blur, and a premium will be placed on transparency, collaboration, and implementation abilities.
We'd like to end with some lessons that we've learned as we work with clients to help them think through their innovation programs and to create a real step change within the environment. First of all, be visionary. Have a vision in mind and targets in mind to guide you. You've got to be flexible. It's important to have a technology roadmap, how you know where you're getting from today to the future from a technological, organizational, and infrastructure point of view. But keep your options open. Technology changes, needs change, and so should you. Be systemic. Look at the entire system. Don't just fall in love with one piece of technology. Instead, look at the entire system from soup to nuts and ask yourself, how does this create a step change? Finally, be prepared. The thing where innovation fails is in adoption and implementation. It's the human factors where things tend to go wrong. Technology usually works at some point. It's important to be collaborative. You've got to use new models, work with suppliers, work with other mining houses, even find ways to collaborate internally and with stakeholders to create new ideas and solutions. Be strategic. Make sure that you're aligned with senior management and be there to guide senior management and help them understand how technology and innovation can fundamentally change the basis for the company. And last but not least, be clear. Communicate, communicate, communicate. Understand who your stakeholders are and what matters to them, and drive your point home and the benefits of your program over and over and over again.
Virtual Consulting International has the experience, the capabilities, and the tools to help organizations think through their strategic challenges and deliver on an innovation initiative.
We thank you very much for taking the time to listen to our presentation and learn a little bit more about what we offer. If you have any questions or you would like our assistance, please feel free to reach out to Jeff and I at the New York office for VCI. Thank you very much.
Thank you.